Hi everybody, this video is just how to use your reference tables. So if you need standard temperature and pressure, here it is. It gives you the values and the units. So kPAs are kilopascals, so that's a pressure unit. Or if you want it in atmosphere, standard pressure is 1 atmosphere. Down here, table B gives you HF, HV, and C. Those are for doing your heat formulas. Here's some prefixes that you see frequently. Here are some other units that you see frequently. So if you're not sure about a unit or a prefix, you can check on this first page of your reference table. Next page, polyatomic ions. So these are ions because they have charges, but they're already in a covalent bond, and so I call these the teams. The teams stick together and you always use their name. So if I have something bond with CO3, first of all, it's going to crisscross a -2 charge, and I'm always going to name it carbonate. So for example, if I had sodium carbonate, Na is a +1, CO3 is a -2, I would have Na2CO3, and the name would be sodium carbonate. I keep the names just as they are. The charges, the names stay the same. Down here, table F, this tells me if something is soluble or not, and if it's not soluble, if it's insoluble, it's going to form a precipitate. So if I put Na with anything, so this NaCO3, that is soluble. But if I put something else with carbonate, you'll see carbonate over here. Carbonate is insoluble. So like if I put it with calcium, that's a group 2, so it's not on the exceptions list. Calcium carbonate would be insoluble, and that would form a precipitate. Over here is table G. This tells me how many grams you can dissolve of different solids, liquids, or gases. So let's say I'm looking at potassium nitrate and I want to see how many grams I can dissolve at 60 degrees. I find the curve, I find 60 degrees, I go up, I go over, and that tells me about 105 grams could be dissolved in there. All right. Next one's table H. This tells me vapor pressure. So I can calculate, well, first of all, I can see as vapor pressure goes up, boiling points go up. Here's my normal standard atmospheric pressure. So this is the temperature at which propanone would boil, 60 degrees. And over here, water, 100 degrees. If I decrease the pressure, I decrease the boiling point. If I increase the vapor pressure, I increase the boiling point. And as I go across, each one of these has a higher boiling point, so this would have the strongest intermolecular forces of attraction, and this one of the 4 would have the weakest. All right, table I gives me delta H's, heats of reactions. If it's negative, it's going to be an exothermic reaction. It's going to release that much heat. Negative tells me put that value on the right-hand side. If it's positive, that's an endothermic reaction. That means I would have to put the 182.6 kilojoules on the left side of the reaction. It would have to go in for that reaction to occur. You also know delta H does not change because they list it right here on the table. Table J is our activity. So these are my metals. This is telling me how likely is it for them to oxidize. At the top, most likely to oxidize. At the bottom, least likely to oxidize. So that's why gold and silver are jewelry. They're least likely to oxidize on your wrist. All right, nonmetals. These want to reduce. So this is most likely to reduce and least likely to reduce. So you can tell if a reaction is spontaneous if your metal is oxidizing and your nonmetal is reducing, or if the metal that's oxidizing is higher than the metal that's being reduced. All right, over here, table K. This shows all of my acids, so if I have a question about acids, how to name it, or if it is an acid or not, I can look it up. Here are my bases, and then here's the indicators. So methyl orange. If I put methyl orange in a pH of 1, it's lower than 3.1, so it should be red. If I put methyl orange in a pH of 3.5, it would be in the middle of this. So it would be in the middle of these colors, which is orange. And if I had a pH of 6, it would be on this side, so that means its color would be yellow. So that's how you use table M. Table N shows us our radioactive isotopes. So these are things that spontaneously decay. So 198 gold, it has a half-life of 2.695 days. It decays with a beta, and it's called gold 198. So that's how you use that. If you're writing a decay, here's all of your symbols. So if I wanted to do beta decay, I would show that gold, and I would show the arrow, and then I would show a 0 - 1 being lost from the gold. That's how it decays. If you're not sure about protons and neutrons or mass or an alpha, it's all on here. For organic chemistry, there's our prefixes. So if I have 1 carbon, I use meth as a prefix. If I have 6 carbons, I use hex as a prefix. Here's my homologous hydrocarbons, so my alkanes, alkenes, alkynes. These are saturated, all single bonds. These are unsaturated, double bond, triple bond, and you name them with anes, enes, or ines, and they have that formula. If the H's are double it plus 2, it's going to have all single bonds. If it's double it minus 2, it's going to have a triple bond. Next table is my functional groups. So if I am trying to identify the class, I go and find the functional group, identify what class it is, and if I have to name it, here's all of my examples for naming. Then there's my periodic table, which of course is just a wealth of information, and right here it tells you a lot. The mass, the symbol, the atomic number, the electron configuration, the most likely oxidation states are all listed. These are groups going down, these are periods going across, and there's so much you can get from the periodic table. After it are a lot of values that you can get for any element. So these properties don't change because they list them out. So like density and boiling point and melting point. You could say like, hey, it's 500 degrees. What would lithium be? So you go find lithium and you go over here to 500 degrees. 494, we're past the melting point. So that means it's a liquid, but we haven't boiled yet. So I know if it's 500 degrees, lithium must be a liquid. If it was 300 degrees, it would be a solid because it wouldn't have melted yet. We can look up electronegativity, ionization energy, even radius using this. You can even find the symbol if you're not sure about what an element is. Keeps going. And then my last table is for math. So table T here gives me the formulas for calculating density or number of moles, percent air, percent composition, concentration either in parts per million or in molarity, gas law problems, titration. So if they're asking for molarity, but you can't use this one up here with moles, if they're asking about acids and bases, you use MAVA equals MBVB. And then heat calculations are my Q's, and temperature, there's even a reminder here that if you want it in K, you have to add 273.